Okay, so the next stage is to analyze the running time of this algorithm, and it's not going to be pretty, right? So it's not even completely clear how to attack it and so on. And in particular, the running time naively is pretty bad. Because, naively we are calling here on an array. So, we are going to create this recursive tree. It's going to be a binary tree, right? Because we're trying two possibilities. So it's going to be a binary tree of height n. So naively, the size of the recursion is 2 to the n, and the running time is going to as such to be of 2 to the n, right? It's better than the old algorithm, which had 2 to the n times n, but it's really not wonderful. It's nothing to write home about. So it turns out that we can do much better, and we're going to see it in the next lecture, where the idea is that this algorithm is in fact fine, right? It's a pretty good algorithm. The problem is that we're going to, if you look at the recursion tree carefully, we're going to repeatedly call recursively on the same subproblems. And the idea is that when we are calling recursively on the same subproblem again and again and again, we don't need to do it repeatedly. Once we compute the result, we can remember it and just use it, which is memorization. And then magically, if you do memorization right for this algorithm, the running time improves from 2 to the n to quadratic running time. And that, as I mentioned, we will see in the next lecture. So all we did now was to improve the running time from a terrible n to the 2 to the n to 2 to the 2 to the n, right? Which is not very exciting, but the next step would be really to dramatically improve that. And for that, you should see the next lecture. That is all.